Hi, and welcome to this edition of The Everyday Editor. My name is John Crossman, and I appreciate you watching. Don't forget to subscribe and ring the bell so you'll get updates every time I post a new video. Today, I'm going to get into what I kind of consider a big black hole of the whole television editing business, and that is jargon. The one thing I will tell you about jargon is that depending on where you learn your jargon will highly influence what the jargon is. I started, as you know, at a TV station. We had plenty of jargon in the newsroom that we used to communicate what kind of stories it was supposed to be or that thing. But when I got out into the professional video world, I heard a lot more jargon that I had never heard at the TV station, and come to find out that right next door to us was our biggest competitor, another TV station, and they did the same kind of stories that we did, but they had different terms for what they called everything. And so jargon is highly subjective to where you learn it. If you're coming up, helping film crews, you're going to learn whatever jargon they use, and there's, I'd say, a decent chance that the jargon that they use may be restricted to just, that singular crew. If you go to the next movie set, you'll be doing the same things that you might have done before, but they might have different names. So jargon is a shortcut way of communicating, but it's not universal, I found, by any stretch of the imagination. And some of it can be kind of hard to figure out how they came up with it. But I'm going to start this discussion with something that jargon is also kind of the field that people that are into the technical side of the work really love to talk about. I remember going to a video club that I joined for a while, and a lot of guys wanted to talk about jargon, about technical specs. And I wanted to talk about, well, what kind of projects are you doing? What kind of messages are you making? What audiences are you trying to communicate with? That's the part that interests me about editing and television, is the message, the story, and the audience, much more than the jargon and the technical mumbo-jumbo that some people really get deeply involved with. But that being said, I think it's important that you are familiar with some of the jargon and maybe some of the history of why things are called what they're called. And to that end, I'm going to start with something that you're likely going to hear about when you buy a camera. If you're editing for clients, they're going to bring you footage, and this is going to be something you need to be aware of. And the jargon I'm talking about is a codec. What is a codec? Well, codec is a shortcut of two words, compression and decompression. So C-O-M, C-O, and then D-E-C for decompression. Compression and decompression. And that tells you the gist of what a codec is. A codec is the math, an algorithm that the camera manufacturer or the software manufacturer uses to describe how a video frame is compressed and how it's decompressed to turn it back into a frame of video. Video files are huge. When I was kind of brushing up on this earlier, I believe they said a minute of uncompressed video at HD in an HD frame, 1920 by 1080, would be just under 15 gigs a minute. Well, I don't know how much storage you have on your computer, but computers generally come with 8 gigs of memory. I would suggest you get 16 or 32 for editing. But if a computer's, starting point is 8 gigs, and you think of a minute of uncompressed video at HD in an HD frame, 1920 by 1080, would be just under 15 gigs, twice as much as that. You get some idea of how enormous video files are. And it's because that's how much information there is in a frame. And so codecs were developed as a way to be able to compress video and then decompress it. So when you shoot it, the camera, even a low-level camera, the sensor is going to, for all intents and purposes, capture an uncompressed image. And then it's going to immediately be put through a codec that will decide how the video frame is going to be compressed. And once it's compressed, then that's stored to your SD card or your hard drive, whatever your camera has. You take that to your computer. It recognizes it as a video file. You open up your editing program, in my case, Premiere. And so this camera that I'm shooting this on, it shoots a .mfx file, I believe, which is another part of this discussion. If you are familiar with a .mp4 or .m4 or .h.264 or QuickTime, and there's a bunch of different QuickTimes, those are all, including this camera, an H.264 codec. H.264 is probably the most widely used video codec at the moment. H.265 is popular with the newest cameras. It's also called HEVC, I think, for high efficiency video codec. H.264 you can get as an AVI file, you can get as a QuickTime file, but all of those have their different flavors. So they're using the same basic kind of math to do the compression, but there's lots of ways to customize how they implement the math, and that's the difference. That's why you need sometimes different software to run different videos, even though they're basically the same H.264 videos. Virtually any video you're going to see on YouTube is H.264 or Vimeo. Anything streaming is going to be H.264 because it's a very good compression, allows for good quality of video, much smaller in size, and is tweaked to the human eye. The trick with compression is getting rid of the information that the human eye doesn't really pay attention to. And that's all been figured out over many, many years of studying how people see things. And so the important thing with a video codec is that your camera is going to use a codec to shoot. When you go to edit it, you need to make sure that your computer has that codec available to use in your editing program. So I'm shooting on a Sony camera, EX1, which they haven't made for quite a few years now, but an original HD camera. And when I go into Premiere, there are, I don't know how many, probably at least 100 different codecs that are available inside the program. And so there's two ways in general, at least with Premiere, and I think a lot of other programs share the same characteristics, is you import your footage. You can click on one of your original clips and say make a composition based on that clip. So then it will make a timeline or a composition or a sequence, depending on what your software calls it, that has a matching codec to that clip. And for a lot of us, we're going to edit from footage that all was shot on the same equipment or cameras. So that most of the time is a good way to keep everything organized, and it's also less work on your computer. If your computer only has to manage one codec as it's editing, it's just less work for the computer. Now you may get projects, I've had projects that are shot with different cameras, different times with different codecs. And when that happens, Premiere is written in such a way that it will convert on the fly to whatever the codec I'm editing with is on my timeline or sequence. And so if I bring in video that doesn't line up with that codec, it will actually reinterpret it so that it's turned into the codec that matches all my other footage. And depending on what the codec is, that can either be seamless and transparent to your eye, or you may notice some gradation, some deterioration of the image. But my experience using the software and the cameras that I've been exposed to, it's never been an issue. I've done projects that have all been shot in 4K. I've done projects that have been shot on either Sony's and Panasonic's, which even though they may be the same format, both those manufacturers go in and they tweak parameters basically so they're not compatible. But the software, in my case Premiere, is smart enough that it can look at it and say, okay, well, Panasonic says this, but we're editing on a Sony timeline, so we're just going to fix it so that it plays back on a Sony timeline. Anyway, codec is the math that controls the compression and decompression of a signal. There's lots of different things that are included in a codec. From the internet, here's a succinct description. A video codec, coder, decoder, contains compressed mathematical representations of video data rather than raw frame-by-frame image arrays. In other words, the pictures aren't actually in the file. It's math that's representing the images, which is pretty amazing, the kind of images math can represent. To achieve efficient storage and streaming, it strips out redundant visual information and contains the following core types of information. First, color space and subsampling. Data defining the color model, like YCB-CR, where CB is the color of blue and CR is the color of red, and Y is luminance. And how much color resolution is preserved, for example, 4:2:0 chroma subsampling, meaning that the luminance is sampled 4 times, the blue is sampled 1 time, and the red is not sampled at all. Second, intra-frame spatial data. Mathematical transformations like the discrete cosine transform that describe the brightness, contrast, and visual patterns within a single standalone frame. No, I don't know what that means. 3. Interframe or temporal data. Motion vectors and differential data that track and predict how blocks of pixels change or move from one frame to the next. 4. Compression metadata. Instructions for the decoder on how to reconstruct missing visual details, for example, quantization parameters determining the trade-off between file size and image sharpness. And lastly, timing and sequence, frame rates, timestamps, and synchronization data to ensure video streams play back smoothly. So it keeps track of frame 1, frame 2, frame 3000, 3001, 3002, that kind of stuff. They emphasize that a video codec is not a file format within itself. It is a data stream or algorithm that is subsequently wrapped inside a container format such as a .mp4 or .mkv alongside audio tracks, subtitles, and user metadata. So the codec is simply the video compression and decompression. It does not include audio. Audio has its own codec. It's technical kind of mumbo jumbo that you really don't need to know, but you will find some clients and some customers that, will ask you kind of technical questions. And so it's not a bad idea to get a little familiar with it, and you can obviously search on the internet and find tons and tons of material that explains codecs and whatnot. I am going to share a link right here that talks about how we came up with this 29.97 frames per second in television. That's just a standard in North America. It's not a standard in Europe or Japan or anything else, although Japan might use NTSC. You may have heard the term NTSC. That stands for North American Television Standards Committee, I believe. We used to joke at the TV station that it stood for never twice the same color. As this video that I just gave you a link for will explain, television technology grew out of radio technology. And at first, it was simple because they were broadcasting black and white images. When it came time to add color to it, they wanted to make whatever the new color system was backward transferable to the tens of millions of television sets that were already in the market and were all black and white. And so there were some heavy-duty math that had to be done to be able to add color. But if you ever see a real old videotape of actual standard def, there will be scenes where it will seem like literally the color is kind of floating on top of the picture. And that's really kind of what it does. The color is added after the black and white image. So it's basically broadcasting a black and white image and then adding the color information over the top of it. And depending on the quality it was shot with and broadcast with, sometimes the color can crawl quite a bit on old color TV videos. So, but we're talking about codecs in this podcast, and I'll include some links to more information about codecs, as well as a link to that video that explains why we have a odd frame rate in North America. So that's codecs in a nutshell. In the next podcast, I'll talk about frame size, the difference between standard, high def, 4K, 8K, and how it's measured, and some of the kind of technical shortcuts that were taken to get us to where we are today. Thanks for watching. My name is John Crossman, and we'll see you next time.